Assalamu alaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 9 students. My dear students, our today's topic, Chapter 4 discussion, Part 1. Our today's lecture number is 2 and SW number 1, and this is belongs to for annual term. Okay, now my dear students, this is chapter 4, work, power and energy. The chapter name is work, power and energy. So follow this class with your textbook. My dear students, at first we will learn what is work. We use the term work in various ways in our daily life. A great gatekeeper guarding a house all day long sitting on a tool may claim to have done a lot of work, but the words of physics that is not any work. In terms of physics, the word work is well defined, and in a force F is applied on any object and the object traverses a distance S during the application of force, that is displacement occurs, then the amount of work W is done by the force W equals to Fs. Okay, my dear students, so let's see. We indicated work by W. Okay, W equals to Fs. So here F is force and S is displacement, my dear students. So we can define the work like this. If force is applied on if force F is applied on an object and the displacements of that object towards F, the product of there is called work. My dear students, I am repeating this definition again. The product of applied force on an object and the displacement of that object towards a force is called work. Okay, so now see the work. The unit of work is joule. The unit of work is joule, and the dimension of work is W equals to Fs. From here we can write the force. The dimension of force is, we know, ml per t square, and the dimension of displacement is L. So from here we can write m L square, L into L, that means L square t inverse square. Okay, so the dimension of work is ml square per t square. My dear students, memorize properly the definition of work, unit and dimension. This is important for your MCQ and CQ. Okay, now come to the here force is a vector quantity and displacement also a vector quantity, but the work is scalar quantity. Force is vector quantity, displacement also a vector quantity, but work is a scalar quantity. Okay, my dear students, now come to here. This is a mathematical problem, but this is important for MCQ. Okay, your mass is 50 kg. Here given your mass is 50 kg. You have climbed up a 10-story building. How much work have you done? Here given height of each floor is 3 meter. Okay, my dear students, now see. Here given the mass of your is 50 kg. So from mass we can find out the weight. So we know W equals to mg. This is the W equals to mg. W means weight. So mass is 50 kg and into the g means 9.8. Okay, so 50 into 9.8, that means 490 Newton. So your weight is 490 Newton. And here given that you have climbed up 10-story building and each height of this each floor is 3 meter. That means your displacement is equals to 10 into 3. You have climbed up 10-story building and height of this each floor is 3 meter. That means 10 into 3, this is your displacement. So 30 meter. Your displacement is 30 meters. So now we can we can find out easily the how much work have you done. My dear students, here weight is 490 Newton, but this is also a force. Okay, so right, force is 490 Newton into S displacement means 30. Okay, so the work done by you is 490 into 30 meter, that means 14,700 joule. Okay, this work is done by you. This is the answer. Okay, my dear students, I hope all of you have understood this mathematical problem. You have to practice more mathematical problems like this. Okay, now come to, suppose moving object is coming towards you. You try to stop the object by applying force F. The object pushed you backwards a distance S. How much work done by the force applied you? Certainly you have noticed that this time distance traversed is not along direction of force and rather opposite to it. So the amount of work is W equals to F. W equals to F into minus S. This is opposite direction, that's why minus Fs. Okay, my dear students, now this work is negative. This work is negative, and what do you mean by this positive and negative work? We mean the positive work means the work is done by force, and the negative work means the work is done by against the force. Okay, now come to energy. What is energy? My dear students, we know energy, ability to work is energy. We know this one, ability to do work is energy, and doing positive work, this is that means the giving energy to the object, and doing negative work, that means this is the taking away from energy from the object. My dear students, we know the energy, the unit of energy is joule, also joule. The unit of energy is also joule, and the dimension of energy also ml square per t square. So the unit of energy and the dimension of energy is the same to the unit of work and dimension of work are same. Okay, now come to next mathematical problems. You have moved an object 10 meter by applying a force of 100 Newton on it. So here given the moved displacement, that means displacement here given 10 meter and applied force is 100 Newton. If the frictional force is 1000 Newton on the opposite direction, that means this is the negative force. Okay, frictional force is negative force because this is from the opposite direction. And when then what is the amount of work done by you? That means you have to find out the work W, and what is the amount of work done by the frictional force. Okay, now see, here given the work done by you, W equals to Fs. That means here force is 100 Newton and displacement here given is 10 meters. So 1000 joule here is the work done by you, and the what is the amount of work done by the frictional force? Here given the work done by frictional force is W equals to minus Fs, because here direction is negative, so minus F into 100 into 10. So this is this is 10 Newton. Frictional force here given 10 Newton. Okay, so minus 100 joule. This is the work done by frictional force. Okay, my dear students, practice this mathematical problem. Now come to different forms of energy. Here given the kinetic energy. My dear students, at first we have to know what is kinetic energy, and this topic is very, very important for this chapter. We have discussed earlier that the ability to do work is energy. Everyone of us knows that when an object is in motion, it can push another object and set it into motion, resulting the object moving a certain distance due to the pushing. Making another object move means definitely a force has been applied there, and traversing a distance due to this force means work is done there. Now, therefore, we can say firmly that the energy that develops due to motion in a body is certainly one kind of energy, or this is kinetic energy. And in this previous chapter, we said that the terrible road accidents that happens and the losses that occur are mainly due to kinetic energy. When a bus, truck or a car moves at a high speed, then this huge amount of kinetic energy uses, and we can easily calculate how much kinetic energy is produced by an object when work is done by a force on that object. let an object of mass is m and displacement by an amount is s. So the application of force is F, and therefore work done by W, F is, we know F equals to W equals to Fs, and we will prove that now that kinetic energy Ek equals to half mv square. We will prove that now. Okay, W equals to Fs, and we know another formula, F equals to ma, and F equals to ma, and the S equals to ut plus half at square s, and v square, sorry, v equals to u plus at. My dear students, when the object is in rest, then u equals to 0. So then s equals to, this part will be 0. So s equals to half at square, and when u is 0, then v equals to at. Now we will use this formula here. Okay, so F means ma into s. Here ma, s means half at square. So see here half m a square t square. Here half m, at means v equals to at. So use here v whole square. Here v equals to at. Okay, see half equals to m v square. Okay, my dear students, this is the kinetic energy Ek, and we indicated the kinetic energy by Ek. So Ek equals to half m v square. Okay, this is the another formula. My dear students, practice this formula and prove that Ek equals to half m v square. My dear students, your SW, today's SW number is 1, and make 5 MCQ from this topic and submit this SW on Saturday. My dear students, I hope all of you have understood our today's topic. Practice properly and memorize properly the definition of work, energy and kinetic energy. Submit your SW regularly. See you again in the next class. Allah Hafiz.